Welcome to Math 1200 Trigonometry, Module 1.1, Sets and Introduction to Polynomials. These are sections 1 through 3 in the review chapter in your book. Module 1.1 Opener. In this section and in the first several modules of this course, we will be doing a lot of algebra review. So if you have any questions, make sure you ask in the lab. We're trying to get you to know as much of the algebra that you need for trigonometry, but we can't cover all the algebra. So if you feel like there was something that wasn't covered fully or wasn't covered at all, just make sure you ask for help in the lab. When we get to the trigonometry part, we'll cover everything you need to know. But again, this is not an algebra course, so we can't cover everything. Some important concepts to focus on in this section. We'll be going over the rules for the exponents. These you should definitely have memorized. So memorize. You'll be using them throughout the course. We'll be going over how to multiply numbers and variables and polynomials, how to add numbers, variables, polynomials, etc. But don't let this all confuse you. It's really the same properties as multiplying with numbers. Don't let it get to your head. Variables and polynomials go by the same properties. Probably the most important thing for you to get out of this section is to make sure you have some scratch paper. It's good to start building good habits early on. So take notes and definitely practice the examples and do your homework, but always have scratch paper with you. It's okay to make mistakes and to try things out. Objective 1, understanding the different sets of numbers. Definition. A set is just a collection of objects or elements. It can be a collection of numbers, like 1, 2, 5, or it can be a collection of numbers and variables, 1, x, y, etc. But we use these brackets to represent a set, any collection of numbers or variables. Some important sets are the natural numbers, which is just the counting numbers, 1, 2, 3, etc. The whole numbers, which is just the natural numbers with 0 included, 0, 1, 2, 3, etc. The integers, which is just the whole numbers, 0, 1, 2, 3, etc., 4. Also with negative integers, negative 1, negative 2, etc. The rationals is any combination of numbers that gives you a fraction. So for example, 1/2 is a rational. So is 4/12 because it reduces to just 1/3. It's still a rational number. So is the square root of 4. The square root of 4 is 2. And 2 can be written as 2 over 1. So the square root of 4 is a rational number. So is 0.1. 0.1 is 1 out of 10, or 1/10, because the 1 is in the tenths place. So it can be written as a fraction, and it's a rational number. Any other number, 7, any other integer, whole number, or natural number, 7 can be written as 7 over 1, or 21 over 3. So it's a rational number, etc. Irrational numbers are numbers that can't be written as rationals. It means not rational. So things like the square root of 5, because that can't be simplified. Or pi, because pi is 3.14, etc. But the numbers, there's no pattern to the digits, and the numbers never stop. You can't write pi as a fraction like you could 0.1. So pi is an irrational number. Same thing with the negative square root of 7. That can't be simplified with the square root of 8. The square root of 8 can only be simplified to 2 square roots of 2, but the square root of 2 is still irrational. So anything that is not a rational number. The real numbers are just any combination of all these numbers we've talked about. So 0, -5, 2, pi, square root of 7, square root of 4, 0.3. All these are real numbers. Any of those numbers. Objective 2, evaluating expressions involving exponents. Definition. An expression is just a combination of numbers or variables using any of the usual properties of addition, multiplication, raising of powers, etc. So it's just a combination of any number like -3 and variables like x raised to some power, using multiplication, using addition, etc. So here this is an expression. 5 over x plus 3 is an expression because we're taking a number, dividing it by a variable, adding 3 to it. This is an expression because we're taking 9 times a variable x, subtracting it by 2, and we're square rooting it. All different types of expressions using the usual properties that you know. There's an important type of expression, though, called an exponential expression. And that consists of some base number, or some base raised to some exponent, or power. The exponent indicates how many factors of the base are being multiplied. So for example here, in -3 squared, the base is just 3. It's not -3, it's just 3 that's being squared. And the exponent, or power, is 2. So that means that we're going to have a negative, which we can write as -1, and then 3 times 3, 2 times over. If we write -3 in parentheses and square that, then now that tells us that the base, the thing that's being squared, is the -3. So the base is -3, and the power is still 2. And by definition, that means -3 times -3, 2 times. Five to the 0th power is 1. Because we're not multiplying 5 times any times. So we don't have any 5 times 5 any number of times. By definition, any number, 7 or -7 raised to the 0th power is 1. Any number, even if you don't know what that number is, x to the 0th power is 1. Anything raised to the 0th power is 1. Objective 3, using the order of operations. The following are some important steps in the order of operations. First, you'll always want to simplify or evaluate grouped expressions. So in this example down here, the -2 cubed is grouped. -2 cubed is grouped together, so you'll want to do that first. Same thing with the 3 squared, or 3 times 2. It's grouped together by a parentheses, so you'll want to do that first. The numerator is grouped together in the top, and the denominator is grouped together in the bottom, so you'll want to do those separately. Always do things that are grouped first. Work from the inside out and evaluate any exponential expressions. So here, for example, you don't want to worry about the negative just yet. That's at the outside. You want to worry about that last. You want to worry about things like the negative 2 cubed, because it's grouped together first of all, and because it's in the numerator. Then you want to worry about the negative 3 squared. Then you want to move on, working your way to the outside. Work from the left to the right when multiplying and dividing. Right? And then you'll work from the left to the right when adding and subtracting. But do multiplication and division first, then adding and subtracting. Always left to right. So let's try this problem out. We're going to leave the negative alone. Just put the minus sign there. We're going to work with the numerator first. Leave this minus sign alone and square the 3. 3 squared is 3 times 3, which is 9. Leave the plus sign alone for now and work with this group term, negative 2 times negative 2 times negative 2. Negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is 4, because the negatives cancel, times another negative 2 will give us negative 8. So this says negative 9 plus negative 8 in the numerator. At the bottom, we'll do 5 times 2 first. It's grouped together. 10. Write the minus sign. 3 times 2 is 6. Again, leave the minus sign alone for now. Work with the numerator first. Negative 9 plus negative 8. Negative 9 plus negative 8 is negative 17. Over 10 minus 6 is 4. And now it's easy to see that the negatives cancel out. So this just says 17 over 4. And there's nothing else to simplify. Objective 4, understanding properties of real numbers. The commutative property is a property that says that multiplying or adding numbers does not depend on the order. So you could say negative 2 plus 3 or 3 plus negative 2. The order doesn't matter when adding. Or you could say negative 2 times 3 or 3 times negative 2. The order doesn't matter, but you want to be careful that you keep the signs together. So this says negative 2 plus 3. So on the right side here, we should also have 3 plus a negative 2. You want to keep the sign with its number. Same thing with multiplication. This says negative 2 times 3. So on the right side, you should have 3 times a negative 2. Always keep the sign with its number. The associative property says that multiplying or adding numbers does not depend on the grouping. So it doesn't matter if we say negative 2 plus 3 plus 5 or negative 2 plus 3 plus 5. But again, you want to keep this sign with its number. This should say negative 2 plus 3. This should say negative 2 plus 3 plus 5. And again, the order doesn't matter for multiplying either. 3 times 2 times 6 is the same as 3 times 2 times 6. So order doesn't matter, grouping doesn't matter when multiplying and adding, as long as you keep the sign together with its number. The inverse property of numbers. When multiplying, the inverse of any number x is 1 over x. What that means is that x times 1 over x, a number times its inverse, is equal to 1. So 5 times 1 over 5 equals 1. 7 times its inverse will equal 1. What's the inverse of 7? 1 over 7. Negative 8 times its inverse times 1 over negative 8 will equal 1. Distributive property. The product of any number and the sum of two numbers is the same as the sum of their products. In other words, we can take any number 3 and multiply it by two numbers that are being added together, 5 plus 2 Or we can multiply them first, 3 times 5 and 3 times 2, and then add them together. Doesn't matter if we add first and multiply, or multiply first and add, as long as we do it in the right order. So for example, if we had negative 6 plus a negative 3, remember that this is the same as saying negative 1 times 6 plus a negative 3. And we can multiply this out. We don't have to say 6 plus negative 3 first. We can. 6 plus negative 3 is 3, and then 3 times negative 1 is negative 3. But we can multiply first. We could say negative 1 times 6, which is negative 6, plus negative 1 times a negative 3, which is positive 3. Negative 6 plus 3 is negative 3. So it doesn't matter the order, as long as we use the rule the correct way. The zero product property is very important. We're going to use this a lot later on. And it just says that the product of any number and 0 has to be 0. So 55 times 0 will equal 0. But that also tells us that any number, let's say 7 times some other number being equal to 0 means that this number has to be 0. 7 times something equals 0 means that this number is equal to 0. There's no other way we can get 0. The absolute value definition. Number 1. There's lots of ways of defining the absolute value. Absolute value of any number, a, is the distance of that number from 0 on the number line and is denoted the absolute value of a. We use 2 bars to the left and right of a. So for example, what is the absolute value of 5? Again, it's the distance of that number from 0 on the number line. So we're going to mark 0 on the number line and find 5. 1, 2, 3, 4, 5. The absolute value is the distance from 0. That's a distance of 5. So the absolute value of 5 is 5. What is the absolute value of negative 5? Absolute value of negative 5. It's the distance of that number, 1, 2, 3, 4, 5. There's negative 5 from 0. That's a distance of 5. So the absolute value of negative 5 is 5. Notice the distance is always positive. This distance is positive. This distance is positive. So the absolute value of any number is always positive. Absolute value definition number 2. This is the same definition, it just looks different. Absolute value of any number a is equal to one of two things. If a is already positive, a is already bigger than 0, then the absolute value of a is just that number itself. It's already positive, we don't have to worry about it. If a is negative though, if a is less than 0, then we need to put another negative sign in front of it to make it positive. So the absolute value of a would be negative a. It seems a little confusing, but we could look at some examples. So the absolute value of 7. According to this definition, 7 is greater than 0. 7 is bigger than 0. So the absolute value of 7 is just 7. What about the absolute value of negative 8? According to this definition, negative 8 is less than 0. Negative 8 is less than 0. So the absolute value of negative 8 has to be a negative 8. Negative 8. In other words, positive 8. You see? So this just takes care of any negative numbers you might have by putting another negative sign in front of it. What about the absolute value of 7 minus 13? 7 minus 13 is negative 6. So this is just this absolute value of negative 6. And again, the absolute value of negative 6 is just positive 6. Here's an important way of thinking of absolute values. The distance between two numbers on the number line is given by the absolute value of their difference. That means that the absolute value of the difference of two numbers, so we're subtracting two numbers, say A and B, is just the distance, so this is equal to the distance between A and B. So as an example, if we look at the absolute value of 7 minus 2, another way of thinking of that is on the number line. Let's put 0 somewhere. Let's put 2 there. Let's put 3, 4, 5, 6, 7 there. The absolute value of 7 minus 2 is just the distance of from 2 and 7. That's a distance of 1, 2, 3, 4, 5. And if we work this out, we see we get the same answer. 7 minus 2, absolute value, is the absolute value of 5. The absolute value of 5 is 5. Objective 5, using the rules for exponents. The product rule for exponents. If we have any base a raised to some power m, and the same base, so times the same base raised to a different power n, the product rule says that we can add the exponents. We can add the powers. A, keep the same base, and add the powers. M plus n. So as an example, negative 2 raised to the third power times the same base, negative 2 raised to the fourth power, will give us the same base, negative 2, 3 plus 4 is 7. The base has to be the same. The division rule says the same thing for division. Same base, different power, divided by same base, different power is the same base, and then you subtract the powers. Write the numerator first, m, the power in the numerator first, minus the power in the denominator, m minus n. The power rule says that if you take any base a, raise it to some power m, and then take that number and raise it to some other power n, we can write down the same base and multiply the powers. M times n. M times n. The distributive rule says that it's a combination of the division and power rule. So if you have different bases, a to some a divided by some other base b, and you're raising that fraction to a power m, the distributive rule says that it's the same thing as raising a to the n and raising b to the n. You just distribute the power. These rules are very important, so make sure you memorize them, but also practice and use scratch paper when you're writing these down. Objective 6, defining polynomials. Before we define polynomials, we have to define a term. A term is the product of a number, so it's a number times a variable raised to an exponent. So something like a number like 3, and the variable, say x, raised to some exponent like 2. And it's the product of that. So 3 times x squared. That's a term. Anything of that sort. A, any number, times any variable raised to some exponent is a term. A polynomial is a sum of terms of the form an xn plus a sub n minus 1 x to the n minus 1, etc. So as an example, take any number, let's say 3, and variable, let's say x, raised to some power 5, plus, so that's a polynomial, is we have different terms separated by plus signs, some other number, let's say negative 2x, a different power, let's say 7. That's an example of a polynomial. Usually for a polynomial we want to make sure that the powers are positive. Positive. Operations with polynomials, objective 7. Polynomials are added by grouping and adding coefficients of the same terms. So as an example, you can combine 2x to the 5th with negative 3x to the 5th because the exponents are the same. X to the 5th and x to the 5th are the same, so you can combine this by just adding the coefficients, by adding 2 and the negative 3. 2 and negative 3 is negative 1, and the times x to the 5th. However, we can't combine, for example, 2x to the 6th plus 2x to the 7th because the powers are not the same. Even though the coefficients are the same, the powers aren't the same, so we can't combine them. We just leave it as it is. Polynomials are multiplied using the distributive property. And this is going to take practice, but you should always write this out. So as an example, to multiply 2x plus 5 with 2x squared plus x plus 3, we're going to take 2x times 2x squared plus 2x times x plus 2x times 3 plus, then move on. Make sure everything gets distributed. Everything gets multiplied out. 5 times 2x. 5 times 2x squared plus 5 times x plus 5 times 3. Then you're going to use the rules for exponential expressions to simplify. Remember that the order here doesn't matter for multiplying. 2 times x times 2 times x squared can be read as 2 times 2, which is 4. Then x times x squared. Remember, for that, since we have the same base, x and x, we can just add the exponents. 1 plus 2 is 3. Same thing with the next term. We only have a 2 there, so we're just going to write it. And we have x times x, so it's x to the first times x to the first, so that's x squared. Same thing for the third term. 2 times 3 is 6. And we have one x there. And so on. 5 times 2 is 10 times x squared. 5 times x plus 5 times 3 is 15. Now we're going to combine the like terms. We're going to add like terms. In other words, we're going to look to see what variables have the same exponent, like x squared, and the x's here, and we're going to combine the coefficients. There's only one x cubed, so we're going to write 4x cubed down. Then we're going to move on to the next biggest one, x squared. 2x squared plus 10x squared is 12x squared. 6x plus 5x is 11x. It's a good idea to cross out the things you're done with as you're working them. And then we're left with 15. And we're done. Polynomials are divided using the usual long division process used for numbers. So just like numbers are divided, we can divide polynomials. It looks more complicated, but it's the same process. So if we were to divide m cubed plus 3m plus 1 by m squared plus 1, we're asking ourselves, how many times does m squared plus 1 go into m cubed? We're going to write 0 m squared because there's no m squares there. M cubed plus no m squares plus 3m plus 1. Well, m squared goes into m cubed m times, so we have to put it on top of the m's place. What does that mean? That means that m squared plus 1 times m will at least give you m times m squared is m cubed, but also gives you m times 1 is m. So that's what we mean. M squared goes into m cubed m times, because when you multiply them together you get an m cubed. So m squared times m is m cubed, and m times 1 is m. And then we subtract like we usually do. M cubed minus m cubed is 0. 0m squared minus 0m squares is 0. 3m minus m is 2m. And 1 minus 0 is 0, or is 1. M squared doesn't go into 2m because m squared is larger than m. So we're done. We have that m cubed plus 3m plus 1 divided by m squared plus 1 is equal to m. It just went into it m times, with a remainder of 2m plus 1 over the m squared plus 1. If that's confusing, don't worry about it. Try to practice it as much as you can. But in this course, we'll mainly be using simplifying when it comes to division. So for example, we could be doing something like m cubed plus 3m plus 1 divided by m squared, but we won't do the long division for it. We'll just simplify term by term. So we'll say that's m cubed over m squared plus 3m over m squared plus 1 over m squared, and we'll simplify where we can. M cubed over m squared, remember by the rules of division, for exponents that's m, same base, 3 minus 2 is 1, plus 3, just leave the 3 there, same base, m, and then 1 minus 2 is negative 1. And here we just leave this as 1 over m squared because there's nothing to simplify. And I want you to just try the following. I'll work them out for you, but just pause and see how far you can get on your own. Okay, so hopefully you paused and tried it. For the first example, we need to multiply using the distributive property. So negative 3x squared times x, negative 3x squared times 2, and then so on. Negative 3x squared times x plus negative 3x squared times 2 plus 2x times x, 2x times 2. And simplify. distribute. And then we're going to simplify. And now we're going to combine like terms. The only things that are like are the negative 6x squared and the 2x squared. Negative 6 plus 2 is negative 4x squared. And we're done. So we combine like terms and simplify as far as we can if we need to simplify more. We can also evaluate any type of expression if we know what x is equal to. So here when we say 3x plus 2 squared, since x is equal to negative 2, we could just say 3, not x, but we could say 3 times negative 2 plus 2 squared. And then simplify from there. 3 times negative 2 is negative 6. Negative 6 plus 2 is negative 4. And negative 4 squared is negative 4 times negative 4, which is 16. Try these on your own. Okay. For this division problem, we're going to just simplify term by term. 4x cubed over 2x plus 2x over 2x. 4 divided by 2 is 2. X cubed divided by x is x squared. 2 divided by 2 is 1. And x divided by x is 1. For the next one, we're going to make sure that we use the distributive property first. So this reads negative 2 cubed, the entire negative 2 cubed, and x squared cubed, then times 2 times x cubed. Negative 2 cubed is negative 2 times negative 2 times negative 2, which is negative 8. X squared cubed is x to the 6th. We multiply. Times 2 times x cubed. And then remember, negative 8 and 2 can be multiplied. Negative 16. X to the 6th times x to the 3rd is x to the 9th. And we're done. You should now be ready for your first section of homework. Remember, use scratch paper throughout this course and ask questions.